Hello friends, welcome to my channel. Today we will learn the basic calculations related to the cooling tower. You may be working in production, utility operations, or you want to work for a new project development, and you know that you want to know that how much water a cooling tower requires a day to make up, right? So cooling tower, if you are working in a cooling tower, you may know that there are a number of losses every day happens, that these are the major losses. If we consider this formula, make up water formula, that is d plus e plus b, where d means drift losses, e means evaporation losses meter cube per day, b means blowdown you want to give or you have to provide per day, that is in meter cube. So these are the major losses that happen in a cooling tower. So we'll use this formula for our next calculations. First, we calculate the evaporation loss. Evaporation loss is equal to Q multiplied by Cp multiplied by delta T upon lambda. So Q means cooling tower circulation flow rate in meter cube per hour. See, this formula is very important. You may find number of formulas, but this formula is very basic and you can apply this formula. You will get approximate answers when you use this formula. Q means cooling tower circulation flow rate in meter cube per hour. Cp specific it in kilojoule per kg. As we are using water, so we'll consider the specific heat of water. T temperature in means whatever temperature in cooling tower minus temperature out of the cooling tower, that is delta T. This is the delta T, that is a temperature difference in degrees Celsius. Lambda means latent heat of vaporization. Now let's calculate. We take an example for evaporation loss calculation. So we will consider that we are having a cooling tower which having 300 meter cube per hour of circulation flow rate. The Cp of water, as you know, that it is 4.187 kilojoule per kg, right? So whatever the values we have taken in kilojoule, right? Temperature in minus temperature out. Let's say that cooling tower temperature in is 33 degrees Celsius and out temperature is 29 degrees Celsius. That is, the difference is 4 degrees Celsius. Lambda of water is 2260 kilojoule per kg. Now let's calculate by using this formula. If we apply this formula, we divide 300 by we multiply 300 by 4.187, again multiply by this temperature difference, and will divide this by 2260, that is latent heat of vaporization. We get answer, that is evaporation loss is equal to 2.22 meter cube per hour. Let's convert this 2.22 in meter cube per day. Just simply multiply by 24 into 2.22. We get answer of 53.35 meter cube per day. That is evaporation loss in cooling tower. Now let's calculate the drift loss. Drift loss basically for induced draft cooling tower, it is 0.1 to 0.3% of the circulation flow rate, and its unit is in meter cube per hour. So as we have considered, we are using a 300 meter cube per hour circulation tower, then we'll multiply this by 0.1 divided by 100. As it is a 0.1%, therefore we have divided it by 100. So what answer we are getting? 0.3 meter cube per hour. Let's convert that zero point 0.3 into meter cube per day. Just multiply by 24, we get an answer of 7.2 meter cube per day. That is our what? Drift losses. Drift losses are like a small mist formation in cooling tower. Whenever the water falls from cooling tower, then some due to the windage, due to the wind or fan air circulation, that water gets drifted out with air, that is known as a drift losses. Now let's calculate the COC. COC means cycle of concentration. And you may know that in cooling tower there is as the cooling tower water circulates time per time, its hardness goes up due to the air and other impurities getting in contact. Therefore, in your facility, suppose you are having 500 ppm of hardness water, and the makeup water or a soft water you are using in your facilities 200 ppm of hardness. You just have to divide this 1500 by 200. You get the cycle of concentration, that is 7.5. Now let's calculate the blowdown required. Blowdown is simply whatever the losses, evaporation losses upon, right, and you must consider the drifting losses, right, whatever the losses have happened. Because of that, what happens, the concentration of hardness goes up, because water evaporates, then hardness goes up. That's why we have to divide total evaporation losses upon COC minus 1. If we do for our particular case, that is we have calculated 53.35 is our evaporation loss, right, 7.2 is our drip loss. Therefore 53.35 plus 7.2 upon the 7.5 minus 1, we get answer of blowdown of meter cube per day. 9.32 meter cube per day blowdown we need to give for a 300 meter cube per hour cooling tower circulation. Now let's calculate the makeup water requirement. Makeup water requirement, as earlier we have seen, we took this formula. Makeup water requirement M is equal to E plus D plus B. E means evaporation, D means drift, B means blowdown. If we add all the terms we calculated earlier, then we get answer of 69.87 meter cube per day. And this is simple calculations we can do for our cooling tower calculations. For this case, we have calculated for a 300 meter cube per hour cooling tower. Suppose I enter here 600. If I have a two cooling towers and I just do the calculations using this calculator, Excel calculator, we get answer of 139.7. Means in your facility, if there are a number of cooling towers working and you know the hardness and this all basic things, you just have to do this basic Excel calculations and you get the answer. Suppose you have a 5 cooling towers, and each having 250 meter cube per hour flow rate. Just you have to do 5 multiply by 250. How much makeup water you required? It is 291.1. This is the water requirement for a makeup. If you know this calculations, then you will be able to design your soft water or other water requirement, raw water requirement in your facility. Thank you for watching my video. Have a nice day. If you want more information like this, please comment so I can make more videos related to uh, the chemical engineering of, or design engineering. Thank you for watching my video. Have a nice day.